we have a cubic equation over here, and we have to initially find the values of b and c using the data they've given. Now for this cubic equation, the roots are going to be alpha, beta and gamma. So we know that the sum of the roots is going to be, now the coefficient here is 1. So sigma alpha, in other words, the sum of the roots taken on their own, that is alpha plus beta plus gamma, is going to be negative b divided by 1. The coefficient of the x cubed term, it's 1, so it's just negative b there. Plus minus, that's how the pattern goes. Now the sum of the three roots will be 2. In this case it's going to be 2. So 2 is equal to negative b, meaning b is equal to negative 2. So when it comes to c over here, it's going to be plus minus plus. That will be sigma alpha beta. Sigma alpha beta is the sum of the roots taken pairwise. So alpha beta plus alpha gamma plus beta gamma and so on. So we'd have sigma alpha beta is plus minus plus c divided by the coefficient of the x cubed term, which is 1, so it's just c. Now we haven't been given the sum of the roots in pairs, but we can figure it out using the data that they've given us. We know they've given us the sum of the squares of the roots, as in alpha squared plus beta squared plus gamma squared is given, and that amounts to 3. That is 3. Now we can say that alpha plus beta plus gamma squared, or rather alpha squared plus beta squared plus gamma squared is equal to alpha plus beta plus gamma entire thing squared minus twice alpha beta, twice sigma alpha beta. That would be the sum of the roots taken pairwise. So this is just like the expansion, similar to the expansion of a binomial, but here we have 3 terms, it's a trinomial. So we have been given the value of the sum of the square of the roots, that's 3. So 3 is equal to, and we've been given this value as well, alpha plus beta plus gamma, that's 2. So 2 squared minus 2 alpha beta, 2 sigma alpha beta, and as we saw earlier, sigma alpha beta is equal to c. So we have 3 is equal to 4 minus 2c, meaning we get 2c as being equivalent to 4 minus 3, which is 1, and c is half. So b is negative 2 and c is half. So we can plug those values here now before moving on to the b part of the question, and c happens to be half. So x cubed minus 2x squared plus half x plus d is the cubic equation, and now we need to solve for d. Now to solve for d, we can consider Sn, S sub n, as the sum of the roots taken to their nth powers. So Sn would be sigma to the alpha to the power n plus beta to the power n plus gamma to the power of n. So for example, S3 would be alpha cube plus beta cube plus gamma cube. Now we've been given S2 and S3 as well as S1. S1 is simply the sum of the roots, that's alpha plus beta plus gamma. Now using all the data, we can figure out a value for D. So first let's look at S3 over here. So if we substitute for x over here, let's say we take alpha cube minus 2 alpha squared plus half alpha plus D is 0, because since alpha is a root of the cubic equation, when we substitute alpha, we will get 0 on the right hand side. In the same way, we can substitute for beta, half beta plus D is 0, and same for gamma, plus D is 0. Now if we add all these three together, if we add these three equations together, we get alpha cube plus beta cube plus gamma cube, which is, yeah, we'll write it here, alpha cube plus, so we'll just write S3 here, because it's the sum of the roots taken to their third power, so S3 there, minus, so when you add all these three together, you get minus 2, brackets alpha squared plus beta squared plus gamma squared here, not cube, meaning it's going to be S2 there, the sum of the square of the roots, and here we have half times the sum of the roots taken to the power of 1, that is just the sum, so it will be S1 plus 3D here, 3D is 0. Now we've been given the value of S3, alpha cube plus, no, they haven't given us S3. However, we can formulate an equation here, so S3 minus 2, S2 is going to be 3, S2 is 3, S1 happens to be alpha plus beta plus gamma, which is 2, plus 3D is 0. So we can simplify here a little bit. S3 minus 6 plus 1 plus 3D is 0. Now we can write S3 as S3 is equal to minus 6 plus 1 is minus 5, so 5 minus 3D. We can write it like this and keep it like this for the moment. Now we can, now we have also been given S4, that is the sum of the roots taken to their fourth power. We can multiply this equation by x over here, and then we would get x to the power 4 minus 2x cubed plus half x squared, that's x squared over 2, plus dx is 0, because x times 0 is 0. Now we can do the same thing that we did earlier for S3. So in this case, we would get S4 if we add alpha to the power 4 minus 2 alpha cubed plus alpha squared over 2, and do the same for beta and gamma. We would get S4 minus 2 S3 plus half S2, S2 over 2, plus D times S1. S1 because alpha plus beta plus gamma is just the sum of the roots. Yeah. Now we've been given the value of S4, that is alpha to the power 4 plus beta to the power 4 plus gamma to the power 4. That happens to be 5. 5 minus 2 S3. Now we don't know the value of S3, but we can we have an equation relating S3 and D, which is what we need to find for the B part. So minus 2, S3 would be 5 minus 3D, half S2. S2 is 3, plus D times S1. The sum of the roots, which is 2, is 0. So we have 5 minus 10 plus 6D plus 3 over 2 plus 2D is 0. So we get 5 minus 10 is 6D plus 2D is 8D. We get 8D here. When we take this to the other side, we get 10 minus 5 is 5. 5 minus 3 over 2, that comes to 7 over 2. So 8D is 7 over 2, meaning D is 7 over 16. The final answer for the B part is D equals 7 divided by 16.